Yes.
Well, welcome to the last panel of the day, the Future Architectures for Solid-State Storage. And I'm Howard Marks. I run an analyst firm, an independent test lab called DeepStorage, and Wright for network computing, and have unfortunately been a practitioner in this market for longer than I would like to reveal. Although when I was buying disk drives, they were measured in megabytes with one digit. Our eminent panelists today, let's start with Mr. Tom.
Okay, hi. My name is Thomas Isakovich. I'm the CEO and founder with Nimbus Data Systems. Nimbus Data develops all-flash, multi-protocol network storage systems.
Okay. So I'm Vijay Karamcheti, Chief Technology Officer, Virident. Unlike the box guys on the panel, we do build a PCI Express, flash drive, the different types of things. Yeah.
So I'm Jonathan Golick. I'm the software CTO of Violin Memory. We build an all-flash Tier 1 primary storage array, network attached or PCIe attached.
It's a box.
A very good box.
I'm Dave Wright. I'm the founder and CEO of SolidFire. SolidFire is building a scale-out all solid-state storage system for large cloud computing environments.
So basically today, we want to talk about what comes next. And we've come a long way with flash, but there are going to be limits at some point relatively soon. And we want to talk about what happens when we hit some of those limits. So Robin, who gave our keynote address, blogged recently about he thought that 2.5-inch SSDs were a dead-end form factor for solid-state storage systems because of various points that he mentioned in his keynote. Have we got any comments from the field?
So I'll start. I think it's less to do with the 2.5-inch form factor itself and whether or not it's dead or going to survive the test of time. It's more about why people are gravitating towards that. Right? So in some sense, in the server context, one of the values that has been put forward for trying to wrap even PCIe SSDs in a disk form factor is the serviceability angle, which is that if you have your PCIe cards attached as disks in the front of the chassis, you can do things with them that you cannot do if the cards are somewhere in the back of the server. You need to kind of do that. And I think that's the way I would answer that question. Is there a natural form factor for flash-based devices? Other than saying that you want to pack them as dense as possible in a place where there's reasonable cooling, reasonable power, I don't think there's anything sacred about the form factor, frankly, from the way we look at it.
Okay, so
I think the form factor is driven completely by the legacy vendors trying to maximize the investment they have for HDDs. I mean, if I want to make an enclosure that can work for HDDs or for SAS drives, I pick form factors that match the HDDs. 3.5, 2.5, and eventually 1.8. That's where the HDDs are going. And from an enclosure management point of view, and amortizing my investment across a lot more environments, that's why those form factors got created. There's nothing to do with what's good or bad about flash.
Dave?
I would say that there is a large value to standardized form factors. There is a significant value in the industry to have multiple people building drives and building flash devices that use the same form factors so that storage system vendors and people building flash architectures can actually have a nice variety of things to choose from, can have a choice in vendors and not have to tie themselves too directly to one flash chip, one flash architecture, one interface standard. Now, 2.5-inch and PCI are the form factors of choice today. 2.5-inch SAS attached and PCI are the form factors of choice today. I hope that we see improvements in those form factors going forward because they are not optimal for flash. I think DIMM-based form factors standardized across the industry would be nice to see. I think 2.5-inch or smaller drive bay form factors that are PCI attached would be great to see, and there are efforts underway to do that today. So I don't think what we have today is the end-all be-all, but I am excited and waiting for the day when we have some new flash optimized form factors that are industry standard and not vendor specific.
So we've recently seen the 2.5-inch PCIe SSDs.
Right.
Dell and HP in their latest generation of servers are supporting those.
Yep.
And now we get the standards battle because we've got SCSI Express and NVMe coming along.
The only thing better than standards are more standards.
Best,
Sorry.
good thing about standards is there's so many of them.
Well, good thing about standards, it takes a while to stabilize. I think
Right,
that's what
and
you're
so-
seeing in the industry at this point.
And so the question is, for the kinds of systems that you guys build, which are a step up from I slapped a SATA SSD in my server, when are we going to see those plug-in higher performance architectures hit the market in any kind of massive way? And I know, Dave, you're going to go, we don't need them because we build our own DIMMs.
Okay. So who wants to go first?
Okay. Good.
So I'm going to phrase, I'm going to interpret the question in one of two ways, in two ways. One is that, when is Virident, if I take, a specific company, when is it going to offer PCI Express, NVMe drives or SCSI Express drives? And I think the answer that at least we have come to is the right time frame to intercept the industry there is when it's more than just a physical form factor, but you have the entire software and operating system ecosystem to support it. So in the context of NVMe and SCSI Express, this requires cross-operating system availability of drivers that are part of the stock release. So that you can actually, so you truly do get the benefits of standardization, that you have an existing slot that you can plug into. So that is one interpretation. The other interpretation of your question is, are there things that you folks are doing that are not part of the standards, and when will those become part of the standard? And the response to that question is, at the time that there stops being a significant competitive advantage, for us, that's where our intellectual property is.
I'm kind of working under the assumption that you folks are a little bit closer to the standards bodies than we are.
We are,
So-
right.
And I'd like to know if this is next year or
So-
2020.
So I think the NVMe, and SCSI Express standards, you'll probably start seeing products in the market in the, I would hazard, late 2013, early 2014 timeframe.
So
There'll be earlier deployments with that, but you'll probably, for all practical purposes, with the full support up and down the stack, it'll be that time frame.
So I think 2013 for NVM Express, it's going to be, I think, a little bit longer for SCSI Express.
Definitely, I think, given the stability here.
The primary issue is the standards happened, but the standards are being pushed by different people that are making the flash devices. So that's what's
Right.
unusual. Is
they're
being-
actually being pushed by the consumer, by the next step up in the food chain.
Yeah,
the
well, actually,
server
one,
vendors.
yes. So it's the server vendors. They're trying to, one, they're trying to commoditize the industry-leading flash card vendors, and you can all guess who those are. And they're trying to take away their, if you look at how PCIe device drivers work now, the PCIe cards, they're all about having this thin or thick software layer depending on the vendor. The thicker it is, the more functionality it has. That's the claim, the more server resources it takes. NVM Express is trying to commoditize that value add, saying, look, don't even put a device driver on our server, just use the standard, and it'll be great. And of course, the flash card vendors who have thick drivers, they don't want to be commoditized. They don't want to just be a bag of parts. They don't want to be a component sale. They want to be a driver with extra functionality. And because they have competing market, they're against each other in this. That's not a great mix for a standard. Okay, if the people who are producing the components are in a war with people who are defining the standards, that's not a recipe for getting things out to the market fast. Now, once the NVM Express drivers and SCSI Express get out in the wild and customers say, you must do it or I won't buy your card, that's the only time it's going to happen.
So,
Okay.
from-
Well, Dave, Tom, you guys are potentially those customers.
Yeah, so from my perspective, the thing that would hold us up from adopting it at this point is really two things. One is the density of the solutions. So the solutions in the kind of 2.5-inch PCI form factor that have come out today are not very dense. So it's maybe 2 or 4 drives per server, whereas we can get 10 drives in one U with a 2.5-inch SAS form factor today. And we'd like to get denser than that, not less dense. So density is definitely a challenge with those solutions today, and we would wait until they're at least at parity with what you can do with SATA or SAS before we would adopt them. And the other challenge is obviously cost. As long as that's seen as a niche and as simply a super high performance alternative, and those products carry a significant price premium, it doesn't play well in terms of where we see our value, which is taking flash out to the widest array of applications in a cloud environment where the fundamental cost is very important, and we're not willing to trade a large amount of cost for a, frankly, relatively small amount of performance?
I think it comes down to economics. For us box guys up here that are building platforms from the ground up, if we can achieve better rackonomics, meaning better density, better power consumption, reduced cooling requirements, reduced fan speed, fewer components, by going to a proprietary flash module or SSD design, I think it's going to make sense for companies like us to do that.
And so far, the promise I'm seeing from those isn't that, it's more throughput.
It depends, I think, mostly on the interconnect. If it's going to be, a lot of the, for example, there's one company I know that has a DIMM form factor SSD, except that it's
with a SATA connector.
Okay, but I think more of this form factor, we'll figure out our own form factors here. I think the form factor for SSDs going to other things is really more looking at the blade servers and those sort of embedded opportunities where it's going more and more into the server, and you really do have a finite amount of space.
Right.
You got to shrink things down.
And on a blade server, if I can get smaller SSDs, I could put more DIMM sockets on it for RAM or another processor, and that's going to be a big deal.
Like a VLP form factor flash module that's maybe half a terabyte per DIMM you'll fit way more than you could in a blade server than you ever could with a 2.5 inch. So I think it's in that market where it gets interesting.
Okay. So, as we all know, Flash is weird stuff.
No.
And and there was a paper at the recent FAST conference which had a great title, The Bleak Future of NAND Flash Storage, that investigated how Flash gets weirder as the geometries shrink.
Yes.
And several of our discussions today have worked under the assumption that solid-state storage costs are going to come down following Moore's law. But Moore's law works because Moore actually said the transistor density doubles every 18 months, which means the geometry shrinks, which makes it weirder. Where do we hit that wall? Right now we're at 20 some odd nanometer geometries. Is it the next generation? Is it the one after that? I mean, I think it's pretty clear by the time we get that Flash isn't going to work at 3 nanometer geometries.
I think I think we have several years, to be honest. First of all, I think a good 4 years, 5 years before we run out of geometry. But the other argument I'll make a couple points. First is if you look at the areal density achievements at the 15K drive level, they have been slowing down dramatically, and it hasn't stopped people from continuing to buy 15K disks. SATA areal densities have improved quicker than they have on 15K disks. So just because we can't continue to shrink the nanometer every single time doesn't necessarily mean we always have to hop on the gravy train of the smaller nanometer size.
If it stops getting cheaper but it's still a good idea, that's fine.
Correct. So I think we've got some runway. I think the second thing too, I'm sure everyone said drives were dead on areal density 5 years before a new technology leapt it forward for another 5-10 years.
They also said Moore's law can be continued.
Yes.
Right.
So
and finally,
they made all kinds of projections. Yes.
But the UCSD paper is interesting. Academically, intellectually, I believe it's 100% honest and they're correct. There is a little bit of an axe to grind. They've got more money invested in phase change memory research than anybody.
But that's our next question.
Well, and I love it. Let's do it.
Well, I'll also say that, so you're right, we're already at the point where things are getting strange even the currently shipping process technology. I mean, if you look, that's one of the reasons why we start from chip level and we have Toshiba and we actually talk to them deeply.
And they just invented this stuff, so they might know something about it.
Exactly, but it's really so building your own flash controller. You could say, I remember I was at LSI last company and there was debate: should we have our own flash controller? Because in the beginning of Flash, everybody was doing their own controllers,
right? And
that sort of commoditized down because it got harder and harder for people to make a flash controller without actually having a developer relationship with a NAND flash vendor, because things kept getting weirder, and they progressively get weirder, and that is actually a barrier that's actually there now. There's a reason why people are using consumer SSDs or SandForce technology. Well, I guess LSI now technology. They bought SandForce. Is fewer. There's only a few NAND vendors, and they're not going to talk to everybody. They're not giving everybody the inside scoop of this is how this works in this bizarre fashion as you shrink things down.
Well,
so I think in many ways we're already
there's the economies of scale. If you're Indolix or Sandforce or Marvell,
Exactly.
making millions of those things, they're going to be a lot cheaper than something you build from an FPGA.
But actually, it's,
They'll be a lot cheaper, but they'll be optimized potentially for the different use case than the ones that you need in the enterprise.
Right.
Exactly.
Right?
And
And so there's always a trade-off, and I think that the point that Jonathan made is important. It is, in some sense, I think all of us here, to different extents, the value that we bring is managing that flakiness of flash as it goes towards smaller geometries. Now that said, it's not as if it's next year it's going to fall off. I think Samsung is investing in a 10 nanometer fab for NAND flash. So there definitely is at least 3 process generations from where we sit that are spec'd out. And there are a lot of things that are happening at Toshiba and at Samsung and the other big players that have a way of working themselves out and kind of somehow always extending the life more than what people predict it to be.
But it's going to fall off rapidly next year. How many people can make those controllers?
Definitely.
Because we've been stable on.
Samsung investing in a 10 nanometer thing. They have this very deceptive practice in their press releases where they say 10 nanometer class, and that means anything from 19 nanometers to 10 nanometers. So
19.999.
they're going to be making 10 nanometer flash using that fab.
But what's interesting is the reason why there were so many people who were able to make flash controllers over the last couple of years is we've actually been pretty stable in a process technology for flash for a couple of years.
Right.
And I still think it's going to last, that level is going to last for a couple more years. But the next hop down is going to
Yes, definitely,
push a whole bunch of people out of the market.
Absolutely, yeah. No, the 1X is going to push people out.
That's what's going to happen. So yes, what's going to change next? That process technology move is going to knock a whole bunch of people who are making controllers out of the market.
But I think it's important to note, and Tom touched on this a little bit, is beyond process technologies, there are other things that are going to increase flash density and decrease flash cost. So certainly one is simply volume, right? Even if the process technology doesn't go down, the volume of flash being created is continuing to go up almost exponentially. That will, as more fabs come online, as the process technology at whatever level we're at gets better and more refined, that cost will continue to come down.
Increasing yields is going to result.
Increasing yields always
Absolutely.
will bring down cost. The die stacking technology, the other things they're doing to put more dies in a small package is continuing to improve, again, increasing the actual density there. And the bottom line is the form factors, as we talked about today, the form factors that are standard are certainly not optimal from a density perspective. So as we get into better form factors, density will continue to increase and bring costs down accordingly. Maybe not on as steep a curve as we've been enjoying so far, but it's got a runway to go, and that leads into what's going to come next, I'm sure.
So one other comment on that. I think there's another degree of freedom, which is, interfaces from applications, and I'm probably repeating myself since the morning, but interfaces that actually expose some of the weaknesses of Flash that allow applications to react to that weakness. And I think the Nimble folks have kind of made a big deal of why they don't need RAID, because they use it as a cache, because one assumes that their software essentially manages potential issues. And I can see a wider applicability of those kinds of interfaces as we move forward as well, which will allow people to manage this a little bit better than they are at this stage.
I think also one comment, and this goes back to one thing Robin said in his presentation on ReRAM, is for us to predict the death of Flash, one must have an answer for what that successor is.
And that actually is our next question.
Not
I've
in the
seen
Chicken Little
several
story.
proposals for what comes after Flash, from ReRAM,
I think
which most people probably know better as HP Memristor technology,
Yes.
to phase change memory, to my personal favorite, just because it rolls off the tongue, spin torque.
Yes.
And what is interesting about this proposal is every year there's a new one.
Yes.
But none of them, the one thing Robin pointed out that I think is very astute is that Flash was able to get to this point in the enterprise because it had the consumer volume production business creating all these fabs and driving the cost down. So it's almost counterintuitive, but to find the next enterprise technology, you almost need to ensure that that technology gets adopted in the consumer space first, so you can get the manufacturing scale to drive down
Which
costs.
unfortunately puts us in a really ugly conundrum, because TLC Flash is so cheap that this new technology has to be competitive with that in the consumer space.
And that's the interesting is I get talk to customers all the time. They say, "Well, what comes after Flash?" And I say, "You'll have 2 years of warning because Apple will be shipping it." Okay? I mean, you want to know who decides what flash costs, what its reliability levels are, what its endurance level is? It's Apple. There's one company that defines really all of it, and all the enterprise storage guys combined is in the 4th decimal place of flash in terms of capacity, in terms of volume. Now, if we shift that curve,
By that, you're also saying SLC is that 4th decimal place.
I'm talking about MLC.
Right, but
But SLC is even farther down.
That's the 8th decimal.
Yeah, I was gonna say, I don't know how many zeros, but it's probably more than one.
right.
So when you look at it, we're going to know what the next technology is years before it's cost effective for us to replace flash with it in storage, because Apple is the engine that's driving the curve.
Well, so the other end, though, that I think this could come from is if the next technology, rather than being an immediate replacement for flash, actually comes from the other end and is initially a replacement for DRAM.
Exactly.
A lot of these technologies that you mentioned do actually have latency characteristics that are competitive with DRAM, have the endurance necessary to replace DRAM, and you suddenly get in a position where you could easily replace, say, 256 gigabytes of DRAM in a server with 256 gigabytes of some non-volatile memory technology in a server, essentially using it as DRAM, but now it has persistent characteristics as well. And that's going to drive all kinds of interesting things, going back to the caching discussion and other things. Yep. All kinds of new things. If every server, if your Intel chip ships with it on the same chip 256 gigabytes of non-volatile memory, because they can.
Yep.
Well, the hell with servers. You're talking about the instant boot laptop.
Yep.
If I am unfortunately old enough to remember computers with core memory as main memory, which was non-volatile. And we would take the PDP-8 and turn it off at night to save power, and you would turn it back on, and it would come back right back where it stopped.
But Dave has a great point, which I totally agree with, which is where these new storage, we look at them as storage technologies, but what Apple is going to look at it from a point of view is low power DRAM. Okay?
Right.
And because these things won't be quite as fast as DRAM, but Apple doesn't really care. Not for the consumer devices. They'll be close. They'll have the long lifespan of DRAM. But they'll be so much more power efficient, and it's power that drives the consumer space. It always has been.
So at Virident, we've been a big believer in that since the very beginning. So in the memory class, storage class memories, we definitely consider phase change memory and resistive RAM as being the most likely candidates. Now, I think as I've been on panels like this since the very beginning of the company. It's very interesting, and this is the first year that resistive RAM has kind of got into. Till last year, it was phase change memory that everybody believed in and thought that was imminent. I think the fact of the matter is, in the last 25 years, really, we had two memory technologies that have really made it out there, right? It's DRAM and NAND and flash.
Right.
And everything else has been in research forever.
Well, to the point where we no longer just call it RAM, we call it DRAM.
That's right. Yes.
That nobody thinks about the fact that there is static RAM and other kinds of RAM.
That's true, right? And so those are really the new technologies that have made it out there, and it is challenging. But it's and I wish people who are working on it the very best. But I think for people like us, how it changes, and so for us, the way we have internalized it is, it changes the system architecture. One has to get used to putting multiple kinds of non-volatile memory in a solution and be able to deal with it. Because and you would either do it because TLC doesn't give you the endurance you want, or because you cannot afford the amount of PCM or resistive RAM that you can put in a cost-effective solution. But you have to internalize that.
What's interesting is if you think about how, I don't know if you ever read the 5-minute rule from Jim Gray and the revised version that said this is why flash is not bubble memory. So the 5-minute rule is, when is that storage technology going to last? It's what you can, it's a cost of caching it for 5 minutes. And it's a great research paper, and it's been proven true for decades now.
I'll have to look that up, because I used to have a TI Silent 700 terminal with bubble memory in it.
Yeah. But what's interesting is, if we're right in what we're saying, that it'll be a DRAM replacement, and the driver will be power, that's actually a different rule.
Well, it's a different rule
Based on cost.
It's based on cost of power, and it leads us to a very different architecture.
Exactly.
The vast majority of what we've done with solid state storage so far has been disk emulation. That we have multiple layers of abstraction surrounding it, but basically we're saying we're using this as a faster disk.
Yep.
our friends who are not here today from Fusion.io and our friends from Virident who are here today have been talking about not disk replacement, but memory as a non-volatile memory.
Well, to be precise, not memory replacement either. It's not just a slow memory. It is persistent memory, it's asymmetric, it has its own characteristics. So you have to kind of treat it as its own tier.
Right, now, this is really a question just for you, Vijay, because
Okay.
the other folks here don't play in this market yet. But I have spoken with the Fusion.io guys multiple times and have talked to other analysts who are very intrigued by the whole idea of treating flash as a unique storage layer and getting rid of blocks and files and talking to it in some native mode. But as I mentioned when I was down on the floor, I've run the corporate IT department. I got to run SAP. If I'm building Facebook, I can write to whatever API you've got.
Right.
For that to be really useful, I need a standard API. I need you and Fusion.io
agree on
and
the
6
API.
other guys to
Yes,
agree on an API that we can build into at least standard languages, let alone operating systems.
So in complete agreement with that, I think when you say that you're changing the APIs by which people interface with memory and storage, they absolutely need to be standard. You have to be able to answer the question, why should I change my application? Given that I make decisions on my application for application launches, if you're an Oracle or an SAP, you plan 3 years out, right? So why am I going to do all this work not knowing what it's going to look like in 3 years? So you absolutely need it to be a standard, no debate about that. Now what can folks like us do to reduce some of the hurdle of crossing this? You can provide interposition mechanisms, you can provide libraries, you can provide tools to aid in the conversion, where to the large part the application itself doesn't change. And if you look at the full software stack, there are enough mechanisms available there that, assuming that the performance benefit or the value is say 50x of writing to the native APIs themselves, there is a significant fraction of that benefit that is available without the end application folks doing the heavy lifting. And I see this being an evolution where those will be the initial solutions that will be available before the larger applications
So
move.
have we reached the stage where there is a standards committee working on this yet?
I think, well, there isn't a standards committee working on it yet because I think it's premature to have standards in the space. You need to show the proof points. And today, clearly, those proof points are being established with the early adopters. No two ways about it.
Yeah, and I
so
think if
those
you
are the
look at
bet-
if you look at the history of, for example, GPU acceleration, it's a good model for this.
Absolutely,
Where
yeah.
very proprietary first came out. Each vendor had their own thing. There was some convergence. There's still some proprietary options available, but some convergence on things like OpenCL, where you had some platform neutrality. I think you'll probably see similar things.
And I think
in
that'll
this
happen,
space.
yeah.
Right, but if we use that as a model, GPU acceleration is what, 7-8 years old from that
Yeah.
first market,
Yeah.
and now it's widely accepted in HPC, but I'm not seeing it in the corporate data center.
And I-
It's
would
not
actually
quite
echo
true,
that.
right? I think what he said is true also for OpenGL and DirectX, which has clearly much larger.
Yes.
But that's because big operating system vendors, their customers drove them to do it, and they wanted the interoperability between cards.
Gaming support is different than,
Exactly.
than GPU computing.
But
But it's a much larger driver.
Yeah,
so
but
yes,
if you look at GPUs right now being, let's use GPUs in supercomputing. Okay, everybody. I started as a computational physicist, so when we had to, when somebody tells me,
have to make you keep it short.
exactly. If we said, look, I've got to rewrite my applications to take advantage of GPUs now. I mean, it took us 20 years to make make workstation superclusters work, rewriting all our algorithms. I mean, literally decades of PhDs. It's going to take many years to make GPUs working with supercomputing.
Okay.
The idea that we're going to make SAP work with each person's private API for using flash as memory doesn't sound realistic.
Why not have a public API? Why not have a standard API for PCIe flash?
So standard application level API is where I think everybody will converge to. I think people are, and that's really what my talk in the morning did say that. It absolutely has to happen. Otherwise, if I were the application writer, I wouldn't convince myself to use it. And how it emerges, whether it emerges through a loose collaboration between companies, or you get 50 standards folks in a room and beat out a standard.
Well, that'll take a couple of years.
Which is probably a bad idea for this, frankly. and the strict evidence of that is what is happening in the NVMe and the SCSI Express forums, because once you get 50 people in, everybody wants to add value and want to make sure that their little pet feature gets in, which probably is not what the world needs at this point.
And that's really why the best standards do emerge oftentimes out of multiple competing proprietary standards, because that creates a competition that allows you to see which features are valuable and which aren't, as opposed to standards that start as standards and never make it that far.
I'm much in favor of de jure standards, of de facto standards, which then become de jure, as opposed to de jure standards, which become de facto because we don't have any choice.
And I think that process is just starting now, and it'll take many years to happen, but it will happen.
Yes, sir.
So the question now, the premise of the question was, how can we treat flash as memory, right, for any of us? I mean, we need to take advantage of the native capabilities and look at flash more like a memory, like DRAM, versus it is a drop and plug and play replacement for the spin writer and SSD. So really the question comes, I think most times, just open it up to the developer world and see what they come up with things, right? I mean, I think a lot of times the standards have been created because people needed certain solutions, right? So I think,
But it's also true that if I'm a developer or if I'm a corporate IT guy, I don't want to buy that single source solution. That even if it's a really good idea that we treat flash, PCI addressable flash, whether it's on a PCI card or NVMe or SCSI Express, as something different than a block storage device. I think that's probably a great idea. But I don't want to be in a position where I have to buy it from any one vendor because I may need some Tuesday. And that guy might not be able to deliver them Tuesday.
The question is, will the standards deliver on Monday for you? Or
That
do you have a chance to
it
deliver on Wednesday?
is a chicken and egg problem. It's less attractive to me because there's no standard, and there's no standard because I'm not buying it.
But let's not forget how really all the PCIe card vendors are integrating in with all the operating systems. I mean, they connect in as a SCSI mid-layer, but they also all provide a block interface, because a block interface is effectively a standard API that bypasses a huge fraction of the software stack. I mean, the reason why they want you to access it in different ways is because there's 30 years worth of code that's really slows you down. Mm-hmm. And so, in fact, Virident, Fusion.io, OCZ, Stack, all of these people, they actually are interfacing at a higher level than disks. They make a block device appear. And I don't mean a fiber channel block device. I mean like a Linux block driver, logical volume layer. The only question is whether they should move it up yet another layer and find a new OS. Well, actually, that's the top of the OS layer reasonably.
Right. But do we want to move up?
Do they want to move into the application?
Go to a higher level of abstraction?
And once you move into the application layer, now it fans out enormously. You've got to convince the application guys that it's worth their time to rewrite their app. And if anybody's ever tried to get run a machine room and try to get somebody to say, you know what, use Oracle 10, I want you to use 11. That's just staying within one database and with one vendor, and that's a heavy lift.
Just convincing the DBA that an index would help takes months.
But that is a place where open source can play a big role.
Yes.
Because either the vendor or, in some cases, a user can decide this is important enough for me to do. I'm going to write a storage engine for MySQL that uses this API, and in fact, we have many examples of even entire companies building storage engines optimized for Flash on MySQL. That opportunity is there, sidestepping what would normally be a 3-year development cycle at a large vendor to get something built.
Yep.
And because of the broad adoption of open source technology, those things can start to become adopted even if they're interfacing with initially proprietary APIs. So there are entry points for this technology to get adopted and to grow over time to the point where it becomes standardized.
And I agree with Dave. That's the reasonable place, I think, for this thing to adopt. It's not at necessarily the OS layer, but at an application engine.
Right.
A major application engine.
No, the database engine.
Because then the end
is
user,
really the
it's
driver.
binary compatible. I don't even see it.
Yep. Yes.
Did you have a question?
Yes, I just wanted to add to what Dave said. Like Apple is driving the Flash, it's possible that open source and more the cloud vendors could drive these API, because if everything is going to the cloud, they have a very good chance of coming with their own API and pushing it out.
Is everything going to the cloud?
Everything's going to the cloud.
Okay,
The
right.
other thing, The other opportunity I'll say is the other opportunity for adoption is in the storage arrays, in the storage systems, in the places that are building, network storage systems out of these PCI cards or other things. There is obviously a benefit and a desire there to have as good of integration as possible, as good a performance as possible, and the issues with lock-in aren't as great there because that's already a component supplier, it's already a vendor that they have a long-term relationship with.
And several of the hybrid vendors are buying specific PCIe cards to provide the flash in their systems.
Yeah.
And it would, in fact, surprise me if they weren't taking advantage of the don't treat it like a disk API is available there. But again, that's now I as the customer are not buying that.
No, you're not. But I'm just saying that in terms of the value of that and getting adopted, there are other routes where that will start getting used.
Absolutely. Right. So you want to go after applications that people own or that have very narrow interfaces. You don't want to move the entire world. You want to move a few and then leverage.
Right. Well,
it.
that's why it's so attractive to the
Yes,
Web 2.0 world,
yes,
because they're one application, 7 million instances. All right. I'd like to open the floor to questions in general. What are you folks waiting for before you convert to solid state storage?
They have already converted. It's a public question.
Buyers.
Oh, so we're just preaching to the choir here?
Absolutely.
Yes, Stephen?
I have a question. So, with regard to having a standard interface for storage devices generally, one of the big differences between SSD and non-SSD is really in the fundamental protocol, the storage interface that's used to access it. Basically, if it uses SCSI or SATA or something similar to that, then it's basically an SSD, whether it's a little thing you can hold in your hand or something giant you can mount in your room. Certainly, the PCI folks, one in particular announced that they're on the way toward having other alternative access methods. Will we see similar non-SCSI, non-SATA, whatever, non-regular block storage access? Will we see something like that for storage arrays in the enterprise as well, which will allow storage arrays to be addressed in a way that's not a fake disk?
So
down with fake disks.
I think that's an interesting question, and if you look at, specifically mentioning Fusion.io's APIs that they announced, if you look at some of the APIs they've announced and what those APIs emulate, two of them are, one of them is a file system, and the other is a key value store. And we already have network storage appliances that are file systems or there are key value stores. So really, in some cases, these APIs are about taking abstractions that exist commonly in the network storage world and bringing them into the box on a PCI device. So in some cases, it's actually going the other direction now. Will you have transactional memory going out to a network storage device? Yeah, in some cases, that might happen.
So I think the big issue when I think about the box on the network versus Fusion.io, which is, it's just, there is a device driver with Fusion.io in the server. So adding APIs to the server is almost inherent. Even if, whether they expose it or not, they're there. If I'm, an enterprise customer who's using Fiber Channel, iSCSI, or whatever, fundamentally, I don't want to put, if I can avoid it, I don't want you to install any software on my server. I don't really want you to add APIs to my server.
Well, what
you don't want to add proprietary APIs.
What you probably end up adding is another Ethernet, another protocol over Ethernet.
And
but is that an issue of the protocol for accessing these things not being standard? Because if it is standard,
part of it is I
then
just
you're
don't want to
not
install any
adding stuff.
software on 1,000 servers.
You don't want to, but let's say it comes pre-bundled with your operating system.
Then then it's not an issue. But right now, there isn't
And
a
that's
standard.
really what standards will drive to.
And so one of the things I can see, where these things might go is, we have these RDMA protocols. They are standards. They go over a network, and it wouldn't be a huge lift to add a transactional bit to it.
Well, no, it would be kind of what Microsoft's doing with SMB over
I know.
RDMA in
It
Windows.
is exactly SMB Direct.
Yeah.
And full disclosure, I worked on that at Microsoft. So
Although, in fact, if we look at Fusion.io's file system driver, that is SMB Direct, isn't it?
yes. So if you look at it, there are ways of doing this over a network that don't require reinventing the wheel and are leverage movements we've done to make remote memory fast, remote DMA access.
Right.
And I think that that's the best way to go rather than to make gather APIs into the application.
Yeah, otherwise, of course, there's NFS4, which has some interesting applications as well. You see NFS4 as potentially being a protocol for accessing solid state
So,
storage.
the thing I would say about NFS4 in particular, and the parallel kind of capabilities of that in particular is, obviously that has great applicability to scale out architectures. So if you have a scale out architecture and you have a network protocol that allows you to spread I/O across that scale out architecture, that's a great fit. Obviously, as we talked about earlier, Flash is a great fit to scale out architectures. So the marriage of those three things is potentially very transformational in order to enable large-scale, high-performance, Flash-based network architectures. So I
Okay,
do
but
think
you guys in the back, don't tweet that, he's not making a product announcement. Yes, sir.
Yeah, I have a question. Violin talked about moving the application to the data, and Robin talked about it too, but I didn't hear anything from SolidFire or Nimbus. Do you guys have any thoughts about whether that's a good idea, any plans to go in that direction, or any customers who maybe are trying to use the processing power inside your box to do more data manipulation?
Yeah, it's a good question. And the answer to that is that's not an area we've chosen to focus on because that tends to be very application specific at this point. You are seeing people, for example, with Hadoop, because that application has gotten so widespread that have actually built that into storage systems so they can run some of that processing locally. Ultimately, we are very focused on commodity infrastructure and not building specialized appliances one-off for each application. We think there's great value in having generalized infrastructure for compute, generalized infrastructure for storage, generalized networking infrastructure, and gluing them together in an infinite variety of flexible ways. You can always build a specialized architecture that's the best thing for one particular application, but when you've got a cloud environment, when you've got a large data center, you don't want 100 of those architectures all over the place. You need something that is generalized and has a lot of flexibility.
One way Nimbus is doing that today is through supporting direct NFS. So that's one case where Oracle, for example, and NetApp work together at length to allow for very high transaction rates, low latency over NFS because it was desirable as a file protocol. And direct NFS and RDMA allowed that. So direct NFS, for example, is one of the ways we've gotten closer to the application. I think SMB Direct is sort of another offshoot of the similar concept, leveraging RDMA capability. I've been quiet through the other debate about the standards on APIs because I've been digesting it a little bit, and I've watched this standards activity in storage for, I think, my whole career in storage. And if there's any one industry where the lack of standards will flourish, it's storage. And I think about, for example, applications like EMC PowerPath or Secure Path. Technologies that I think in other industries people would say, you must be crazy. I'm going to load a single driver just to do multipathing on this single storage array that I have. But it's been the norm for a long time. But now Microsoft, VMware, they've put in MPIO functionality into the operating system. Now you see that standard going away. Right. So I think if the PCI card vendors push a standard aggressively, I think they'll get some traction with it initially. Even without an open standard, they could get traction. And it doesn't necessarily have to come to a full open standard before customers start writing to it.
Right. I just want more than one vendor.
Yeah.
I just don't want to be in the position where, wait, the one guy I need to get them from
but if that's
is
true,
out of stock.
Then the conundrum is, why are the PCIe flash vendors aggressively acquiring caching software solutions that may end up ultimately proprietary to their PCIe cards? If that intelligence has to be open, well, it could be defensible or it could be revenue expansion, I'm not so sure, but it seems to me that intelligence as well invariably has to move into the OS or into the hypervisor layer and away from sort of a proprietary, this is our caching solution, but as long as you get PCIe cards from us.
Now you're talking about a subject near and dear to my heart. Since
Unless there is a value in interfacing.
Research paper on that.
No, unless there's a value in interfacing the caching logic with the internals of managing the PCIe card. Ultimately the market will decide, right? If you offer value
and to date, what we've seen
versus
is
bundle software, then it'll stay. If it doesn't offer value, it'll go away.
Well, to date, what we've seen is flash hardware vendors buying generic caching software so that they can bundle it.
Yeah,
right. That's true.
And some of them have decided to bundle it exclusively, and some of them decided to continue to sell it as software.
Mm-hmm.
But it's an interesting piece of the market.
I'd like to also say a little bit more on that question you had. Is it is one thought of having everything being fully generic set of servers, fully generic set of storage and networking, and that is the most flexible. There's no doubt. But the one thing we've learned in the virtualization era is containerized virtual machines are really flexible. And if I can run a containerized virtual machine in a storage array, I don't honestly care. There's no material difference to a user that's not less flexible than if it's sitting on outside servers. It just happens to have much more. It can scale down and scale up. There's nothing that prevents you from running inside the server or outside the server. That's a generic architecture.
You're just redefining the building block with which you're building the rack. That's all you've done.
True, but we're getting more and more processing power in the storage.
Right.
Or you put a Virident card.
Or you put a Virident card in a standard server.
Yeah.
It's the same thing.
Except that we're going to fully HA and fault tolerant architecture, so it's not exactly the same thing.
Yeah.
All right, we've got
Today.
time for one more question.
Today.
So we've talked a lot about old spinning metal hard drives, and we talked a lot about different types of solid state drives. What about the combination of the two with hybrid drives? Where do you see that going in the future?
So, I think this goes back to the caching discussion, right? Because that's what ultimately these architectures are, is a caching architecture. Except now your caching algorithm has to fit on a tiny little chip with very little memory associated with it. So when you talk about the worst of both possible worlds, I think that's pretty much it. And it may be okay for your laptop, but I don't think you're going to see that in any serious server deployments anytime soon, because there's only so much that poor little chip can do to efficiently cache all that
Right,
data.
again, there's also the economies of scale, right? So if you can, it's a very specific use case that you can build it for. You're much better off integrating it at the system level.
You lose a lot of density too. I've noticed those hybrid drives are typically half the capacity of the non-hybrid drives in the same form factor, because I think the electronics to pull it off are taking quite a bit of the limited space that are in there.
I think Seagate would say they sell it now.
So I'll actually answer that one as well, because my laptop has a Momentus XT in it, and they come out at about the same capacity as the biggest drive that was available when they come out, but they don't come out on the same schedule. So the biggest Momentus XT right now is 750 gig, because that was the biggest HDA they had that day.
Right.
And they've come out with bigger ones and they haven't put the cache controller on them. My desktop has a hard drive and an SSD and caching software, because a Momentus XT has 8 gig of flash on it for 750 gig of disk. My desktop has 128 gig of flash on it for a terabyte of disk.
Yep.
And that software is really easy. In a laptop, it makes a lot of sense because the form factor is all important. I got not enough room to put 2 spindles. When you start talking about a server or a storage array, space is not nearly as tight.
Yep.
And having the ability to manipulate the flash to disk ratio to match your architecture or your applications is much more important.
I think I'll echo something Dave said earlier, and I agree with this. Part of what you want out of flash is predictable high performance tier. The hybrid systems, they promise that they're less expensive. I got the cost of disk, spinning disk and the performance of flash.
90% of the time.
Yeah, 90% of the time, but 10% of the time it's really horrible.
And on my desktop, I'm perfectly happy with that.
Exactly. But we're selling systems here. I mean, most of us are selling systems here. And in that world...
It's a passing phase.
That's true. It's a DAS world. You heard that earlier.
All right.
But especially in the cloud is an extreme case of this, because it's, by definition, much larger scale, is I can monetize a predictable performance. I can't monetize something where I spend more because flash costs more, but I get the worst of both worlds sometimes. The fact is, we've all spent years, anybody in storage spent years doing caching technology. And LRU is probably as good as it can be when you don't know anything. But the fact is, it's very hard to predict the future from the past and be always right.
So many PhD students are just ruining that statement.
Yeah.
That's right.
You're being recorded.
Exactly.
We could continue that part of the discussion for several more hours.
Exactly.
But the clock on the wall tells me that we're done. And so I'd like to thank everyone for coming. Stephen would like to thank everyone for coming. Chris would like to thank everyone for coming. Nigel would like to thank everyone for coming. And as George M. Cohan would say, my mother, my sister, and my father would like to thank you for coming.
Thank you.
Well, I'd like to thank most people for coming. No, I would very, very much, again, like to call out, there are a large number of companies that participated in this. The logos are on the screen right now. Thank you all for supporting this. This event would not have happened without the 9 companies listed on the screen. This is the most we've ever done for a symposium, and it shows a lot that in terms of the industry. So thank you guys for supporting this. And now the advertising. So this is day 1 of a 3-day event. So tomorrow and Friday is Storage Field Day. Storage Field Day you can't come to, but you can watch online. And everybody who's been watching this online has remarked on the video and that they were able to follow along. And judging by the conversations on Twitter, at least, there certainly have been a lot of people following along. So if you'd like to see that event, again, it starts tomorrow morning. Some of these companies are going to be there. Some of them, different companies are going to be there. That is basically all day tomorrow and all day Friday. You can also see more about that at techfieldday.com, which is our website. We've already started posting videos. Dave, you're live already because you were the first presentation this morning. To our Vimeo channel, and we'll be putting those videos online at techfieldday.com as well. If there were hiccups in the video, or if you had to leave or whatever, or you couldn't hear, those videos are going to be online very, very shortly, as will all the Tech Field Day videos. So the reason that we're doing this is not world domination or Ferrari purchasing power. It's actually because I love the idea that we can get a whole bunch of awesome people in a room together to talk about cool stuff. And that's what this is. I mean, this is solid state storage is probably one of the coolest topics in storage. I mean, Robin said that this is the most exciting decade in the history of storage, and that means a lot coming from a guy as old as Robin. And it would mean more coming from Howard. Now's the time that I roast everybody, and they don't want to work with me anymore. It is, and this is cool stuff. And all of the conversations were great, and I really, really appreciate the fact that you guys are willing to stand up here and have this, talk about this and have this discussion in public. So, my head is off to you. If there are other companies that would like to join in, we'll probably do this again. In November, we've got another Storage Field Day coming. Hopefully, we will have 19 more companies vying for 8 slots. Hopefully, we will do another symposium, maybe on solid state. If you guys think this is the topic to do, let me know, and I'm more than willing to put it together. And if somebody else wants to get involved, I can think of certain companies that aren't here. They might want to get involved next time instead of just being talked about on stage. So thank you guys again for coming. We're going to have, I think most of the people are probably going to hang out a little bit here afterwards. I know the Tech Field Day delegates who are mostly sitting around that table back there. Everybody who's a Tech Field Day delegate, raise your hand so that everybody can see it. These are the folks that are going to be at all the presentations on Thursday and Friday. Basically, they were chosen because they're independent, influencers in this area. So come on, sit down. I imagine some beverages will be consumed. And let's chat a little bit. So thank you again for turning out. Thanks for staying the whole time. And that's a wrap.
Thank you.